Hello everyone. In this video we're going to be solving a really nice problem from Sweden. P and Q are primes, and we're going to be finding all primes that are in the form p to the q plus q to the p. In other words, we're going to find primes p and q such that p to the q plus q to the p is prime. And this problem was suggested by pi integration 4083. Thank you for the suggestion. This is a really nice problem, and let's get on with the solution. So we're going to be finding p and q. We have an equation p to the q plus q to the p, and we want this to be prime, right? So first of all, notice that the smallest prime is 2, and that's special because 2 is even, right? The only even prime is 2. So now when you take a look at p to the q and q to the p, this number, this sum, is supposed to be greater than 2 because the minimum value for p or q or both is 2. And notice that this sum must be odd because it's prime and it's greater than 2. Does that make sense? Okay. So once we establish that, the rest is going to be fairly easy. We're going to be using some nice algebra and also the modular arithmetic. Okay, so we got to look at different cases. For example, if p and q are both odd, obviously, right? If p and q are both odd, then p to the q plus q to the p is going to be even. Why? Because if p and q are odd, their powers are also going to be odd, and odd plus odd is going to give you even. But that's problematic. Remember what we just said about p to the q plus q to the p? It is supposed to be odd, not even. And this is a contradiction, which means this assumption is wrong. So p and q cannot be both odd. So that means one of them must be even. And what is the only even prime? 2. So without loss of generality, doesn't matter, that's what it means. Suppose p is equal to 2. Then of course in this case, q must be odd, and it's a prime. And so that means q is greater than or equal to 3, right? So let's go ahead and replace p with 2, p to the q plus q to the p then is going to equal 2 to the q plus q to the 2, or q squared. And let's just go ahead and call this r. So r is prime. 2 to the q plus q squared is prime. So this problem is a lot easier now. Now think about some of the values. For example, if q is equal to 3, then r is 2 cubed plus 3 squared, which is 17. It's prime. Nice. If q is 5, then r is going to be 2 to the 5 plus 5 to the 2, which is 57, not prime. If q is 7, then r is going to be 177, not prime. If q is 11, then r is going to be 2169. Again, that's not prime because it's divisible by 3. Look at that. 2 plus 1, 6 plus 9. You get the idea. Same thing for 177 because, again, it's divisible by 3, and 57 is also divisible by 3. So there seems to be a pattern here, don't you think? If q is greater than 3, then we're getting a sum that is divisible by 3. But of course, we can't generalize unless we have a proof. So does that mean r is divisible by 3? And that's a question mark. If q is greater than 3, right? We don't know that yet. Okay, let's take a look. So let's go ahead and write r as 2 to the q plus q to the second again. And now I'm going to be looking at this through the modular arithmetic lens. In modular arithmetic lens, I mean mod 3. Yes, that's what I'm going to look at because I suspect that has something to do with mod 3. So in mod 3, 2 is the same as -1, so I can kind of replace 2 with -1 like here. And then of course this is just going to stay as q squared. You got to remember q is odd, right? We said that because p is 2, q must be odd, so that the sum is odd. What does that mean? negative 1 raised to an odd power like 3, 5, 7, right? It's going to produce negative 1. So this is going to be congruent to, I guess you could also write equals, q squared minus 1. What is so special about it? Well, let's take a look. So we want r is in the form of q squared minus 1, which is difference of 2 squares, by the way. So that's something to think about, right? So now take a look. Q is prime, right? So it can be in one of these forms. It's either 3n plus 1 or 3n minus 1. Now, why am I writing it that way in one of those ways? Because if a number is divisible by 3, it's like 3n. If it leaves a remainder of 1, it's like this. If it leaves a remainder of 2, it's like this. But I can kind of write the 3n plus 2 as 3n minus 1, and then combine these two things into a nice single expression, sort of, with the plus minus. And I know I write the plus minus sign differently, okay? Now, since q can be one of those, and r is 2 to the q plus q squared, remember we got that before, let's go ahead and replace q with 3n plus 1 minus 1. And by the way, we got r equal to, actually I can probably forget about it because what I got for r is much nicer, q squared minus 1. Let's go ahead and use that. And since q is 3n plus minus 1, replace q with that. And voila, square both sides, you're going to get 9n squared minus plus minus 6n plus 1 minus 1. Uh-oh, 1 cancels out and we end up with something like this. This is what we were suspecting, weren't we? Now we can go ahead and take out a 3n, and it's going to become 3n plus minus 2, which means this is a multiple of 3. Therefore, this is not prime. But wait a minute, we want r to be prime, but it's not prime. How is that possible, right? That means if q is greater than 3, r is not prime. It's divisible by 3, so my claim was correct. In other words, let me summarize this. If q is greater than 3, then 2 to the q plus q squared is not prime, which means q should not be greater than 3, so q must be 3. And for q equals 3, what are we getting? We're getting 2 to the third, again, this is going to be a repetition, plus 3 to the second, and that is going to be 17. And as you know, hopefully, 17 is a prime number. Make sense? Now, here's the summary of our results then. P to the power q plus q to the power p is prime for p equals q and, oops, I wrote like p equals q. I meant p equals 2, not q, and q equals 3, or p equals 3 and q equals 2, because they're interchangeable, and those are going to be the only solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.